Let's see here. Okay, so it's 10 o'clock. We're gonna get started. So I don't know who's trying to get in with their phone number again. Trying somebody yesterday. Let's see who this is. So somebody keeps trying to get in with their phone number, and I want to find out who it is. Because if I don't know them, I got to boot them. So give me 1 second here. I'm trying to ask them a question. If that's your phone number there, I need to know who this is, or I'm going to boot you out of the class for the day. I got to have a name. I can't mark you present using a phone number. Come on, help me out here. Okay, next time put your name up there, Enrique, okay? All right, I'm gonna mark these late and we'll get started here. All right, so we're gonna start kind of at the beginning, just sort of a review, and this is intended not to just annoy you, but to get you a little, I mean, you guys haven't been here in forever, at least it seems like you haven't been here for years, because we're all gonna have to take the safety test again when you guys come back, if and when you guys come back. So I'm gonna pull up the class page, and I'm gonna take you to modules here, and this is what we have for today, okay? I put a whole bunch of stuff in here. So basically what I wanted to cover today, and what I wanted to cover today was joiner, planer, table saw, okay? So what I did was I took all the questions out of the safety test that cover those three machines, and they're all here with their answers, okay? For example, true or false, it's your responsibility to make sure each machine is adjusted properly before you use it. True. You should remove scrap material while machine is still running. False. When cross-cutting on the table saw, you should use the rip fence. False. It's okay to run sheet goods through the planer. False. Table saw is the best choice when cutting to length. False. The miter gauge should be used when making rip cuts on the table saw. False. Your materials should be run against the grain on the joiner. False. You may move a guard or safety device out of the way when running machines. False. When ripping on the table saw, if the fence is set to within 4 inches or closer to the blade, you must use a push stick. Your board must be at least 12 inches long to safely use the joiner. 3 things that need to be checked prior to using the table saw, and there's obviously a lot more than this. Blade height is 1/4 inch above your material. Board is at least 12 inches long. The long jointed edge is against the fence. Okay, there's more than that, but that's a good start. What machine is the best choice to accurately rip a board to width? Table saw. What 2 machines are the best choice to thickness a board? Planer and drum sander. What's the 3rd machine that we use to thickness a board? Resaw bandsaw. What machine is the best choice to quickly and efficiently remove large amounts of material from the face of a board? In other words, to thickness a board. It's the planer. 3 pieces of equipment that can't be used with sheet goods: planer, joiner, drum sander. The reasoning behind that is this, and I want you guys to understand the reasoning behind that. Sheet goods come flat, straight edges, square. In other words, all the edges are square to the faces, the ends are square to the faces, the edges are square to the ends, and they come a consistent thickness, so the faces are already parallel to each other. Those are the functions of the jointer and the planer and the drum sander for the most part, okay? We don't have to joint the edge of sheet goods. It's already flat, straight, and square. We don't have to plane the face of a board, okay? It's already flat and parallel to the face, and it's consistent thickness. And we certainly don't have to drum sand it because it's the same thing. It's just getting things down to final thickness, okay? Final, very accurate thickness. So that's the reasoning behind those 3 machines not being using sheet goods, not being used with sheet goods. What piece of equipment is the best choice for flattening, straightening, and squaring the edge of a board? That's the joiner. Our order of operation states that whenever possible or prudent, you should always mill the faces of a board, then the edges of a board, then the ends of a board. Always place the long edge of your material against the fence when ripping to width on the table saw. The maximum amount of material that should be removed with each pass on the planer is 0.125 inches. That is an eighth of an inch. That's equivalent to an eighth of an inch, 0.125. But that answer must be in decimals, because that's the readout on the planer, and the drum sander is in decimals. It's not in fractions. So that answer will be required to be in decimal form, okay? You should never joint the end grain of a board. You walk into the shop with a board that you want to use for a project and you need to get to the right size. Which of these answers is the proper order of operations? That is joiner, then table saw, then miter saw. Faces, then edges, then ends, okay? So that's the definition of the face of a board, the edge of a board, the end of a board. And a very different definition is the face grain, the end grain, and the edge grain, okay? And what I want to talk about is this, okay? And I know this seems old news to a lot of you, but there is a lot of confusion in regards to this. So let's see if we can clarify a few things and kind of get your minds back into this shop a little bit. Okay, I have two pieces of material here, actually three. I have a piece of maple, okay? A piece of red oak that I've stained one side. I did this for the beginning kids so they could kind of see the grain a little easier, okay? And then a piece of particle board, okay? And my initial question in the beginning classes is this, okay? And I want you guys to answer this in the chat, okay? This will tell me if you're paying attention. You're gonna have about 10 seconds to answer this in the chat. And here is my question. It's a yes or no answer. And I'm talking about this piece of material right here. Okay, so you got about 10 seconds, 15 seconds to answer, then I'm gonna shut it off. Because whether or not you know it, teachers are now being asked to send the names of students who they believe is disengaged or not participating in a class, in other words, sleeping through it, to provide those names to the front office so phone calls can be made home to try and straighten things out, okay? So you guys are all saying, yes, it is square, okay? So that's pretty good. It looks like most people are paying attention. I'm guessing I know one person that's not, and let me see if his name popped up here. Yep. I figured he wouldn't be paying attention, so there you go. So I'm gonna type end. Okay, so here's the reasoning behind asking that question in the beginning class. I'm trying to clarify the difference between a board's dimensions, okay, the length, the width, the thickness, and a board's characteristics, grain direction, okay? That's the whole idea behind bringing this up in a beginning class, okay? The dimensions of this board are just under 12 inches by 12 1/4 by 5/8, okay? There's no way to know for sure if this board is actually square as far as our definition in the shop goes. There's no way to know if it's square without using a square, okay? When we say square, we are talking 90 degrees, okay? That's what we mean by square here. It's not dimensions. We're not talking length, width, anything like that. We're talking angles, degrees, okay? On any board that has 4 sides, a top and a back, or a face and a back, there are 12 different 90-degree angles that need to be established before you can start any joinery processes or decorative work or assembly or anything like that. 12 different 90-degree angles need to be present, okay? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, okay? And as you guys know, we have very specific machines and a very specific order in which we process this board or mill this board or make cuts on this board to get all 12 of those angles square, all right? It's very specific in the way we go about it. There are very few exceptions to that rule. Most rules we have in this shop, you guys should know by now, there are exceptions to just about every rule, but these are very limited, okay? Especially when it comes to squaring a board. Okay, we don't do joinery first. We don't do any of that. We get it square. We get it to final accurate thickness. Okay, dealing with the faces. We get it to final accurate width, dealing with the edges. We get to final accurate length, dealing with the ends. Now, on a board like this that has no grain, particle board, right? There's no grain. The only thing that tells you the difference between an edge and an end is the length and the width, okay? The length, the longer dimension, this being just a hair under 12 inches, this being 12 and an eighth, this is the edge because it's longer than the ends, okay? I'm just talking faces, the largest surface area, the largest surface area. Edges, the longest edge, and ends, the shorter, okay? That's just dimensions. Now, grain is a whole different animal, okay? On solid stock, right? Softwoods or hardwoods. We have pine for softwood. We have poplar, oak, maple, alder, and cherry for hardwoods. Grain matters, okay? And the reason grain matters on solid material, there's a lot of different reasons, but one of the biggest reasons we run across in here is the way in which the grain reacts to being cut or machined or milled. You guys should all know by now that when you route end grain, okay, when you're using a router bit to put a decorative edge or round over or something like that on around a board, when you route end grain, there's a good chance that you're going to take a big chunk out when that bit exits the end grain as it passes through the bit, okay? It's generally a lot cleaner cut when it cuts edge grain, right? So grain direction matters. There's a distinct difference visually between face grain, edge grain, and end grain as well. When we glue boards together, in other words, when we laminate, we can laminate for width. In other words, we can glue two boards together, two or more boards together to make a wider board. And we can laminate for thickness. We can glue two or more boards together to make a thicker board, okay? What we do not do is glue two or more boards together to make a longer board due to the fact that we would be gluing end grain. And if you can think of this board, this is how it came out of the tree, okay? This would be end grain. If you can think of this board as just a bundle of straws with the holes in the straws at the top and the bottom, that's basically what we're looking at. And I saw a little example, I should have done this today. I saw a little example a while ago of somebody that took, and they showed the difference between red oak and white oak. White oak was used extensively in sailing ships and things like that where red oak wasn't used. And the reason being that red oak is much more porous than white oak. And the way they showed that is they took a piece of red oak about, I don't know, about an inch by an inch and about 6 inches long and a clear cup of water. And they stuck it in there and they blew in one end of the oak and you could actually see bubbles coming out the other end. The air was traveling through those cellular pathways that go along the length of this. Whereas white oak, you couldn't get any bubbles to come out. It was a lot tighter grain, okay? So this red oak is gonna suck up the moisture and glue like crazy, this end grain. It's not gonna be a strong joint. So when we look at a board like this, we've got face, edge, edge, end, right? We're not talking about grain. We're talking about just dimensions, okay? Taking a tape measure to it. This piece of maple, on the other hand, okay? That's a face, largest surface area we have on the board. That's the opposite face, okay? This would be the edge due to the fact that it is longer than this other surface. That would make this an end, that would make this an end. Although this is physically end grain, not edge grain. This is edge grain, okay? Because of the way this is milled, you can see the grain going this direction in this board. That makes this end grain and this edge grain. But it makes this an edge dimensionally, this an edge dimensionally, and these two ends dimensionally, okay? So it's a difference between dimensions and actual grain in a board. And that is played out when you look at sheet goods. Okay, there is no grain, so edges, ends, faces are solely based on dimensions. Now, some veneers, hardwood veneers, cherry veneer, oak veneer, things like that, they do have grain, okay? But the only reason you need to take grain into account for the most part, okay, is the way it's oriented in a project. Now, there are exceptions to that as well. But so the whole idea behind taking a board off the rack, drawing your parts to rough dimensions on it, and rough cutting it to a more manageable size so you can start the machining process. We do faces first, okay? And we're gonna start do things a little differently in here, hopefully, when you guys get back. But the problem is our joiner only handles boards just barely up to 8 inches wide. So anything over 8 inches wide, we can't really do on the joiner. But the trick on the joiner is this, and let me take you over to the joiner. I think it is, yeah. Okay. So I'm gonna review the joiner real quick. I want to show you guys what I'm talking about real quick. This is the in feed table, okay? This is the out feed table. This is the fence. This is the guard. And this is the cutter head, okay? Now, the out feed table is set. Both the out feed table and the in feed table can be lowered and raised, okay? The out feed table is set so that it is the same height as the edge of the blade at its apogee, at the top of its arc. You can see when I rotate that, my square just barely touches my square. It's moving when I rotate. That's the cutter edge, showing that it's flush or even with the outfeed table. The infeed table is set right now a little over 16th below the height of the outfeed table. That difference in height is your depth of cut. In other words, if I have this set to a 16th of an inch below the outfeed table, that means that every pass you make on the joiner is going to remove a 16th of an inch of material. Okay. Now, why do we use the joiner? Okay. Let me show you something. So you can zoom this in so you can see a little better. Let's find which way I got to go here. Hey, I went the right way that time. Okay. Hopefully you guys can see this. Not wrong way that time. Okay, so you should be able to see the gap here at the center of the board where it's touching at the ends, okay? Also, it rocks a little bit from corner to corner. Let me put it on the back side so you kind of see this. I've got a better example of this, but it rocks a little bit corner to corner. If I flip it over, you'll really see what's going on here. Okay, so it's not straight, it's bowed in this direction. All right, here's another one. Okay, this board has twist to it. Okay, so it really does rock when I go corner to corner. Okay, see what the other side looks like. Okay, so it rocks quite a bit. That's twist. In other words, the board's got this funky twist to it. All right, if you look down it, you might be able to see it. I don't know. Anyway, that's what we're trying to correct on the joiner. Okay, we're trying to correct one face to get it flat. That's all we're trying to do is correct one face. Because the problem is, if we place this board like this against the fence to joint one edge, if we're not flat against this fence, we're defeating the purpose of a fence. We're not going to get a square edge. There is no way we're going to get this edge 90 degrees to this face that we put against the fence if the face isn't flat. Not going to happen. It's impossible, okay? Especially with twist, because your board is sitting against that fence. One end of the board is twisted this way. The other end of the board is twisted this way. When it goes through that cutter, there's no way you're going to get a 90-degree edge to that face that's against the fence, okay? So one face has to be flat first, okay? Now, probably the best thing to do next, well, the thing we're going to do next. Once you've got one face flat, all right, we're going to put that face down in the planer and we'll remove material from the opposite face, okay? That's going to accomplish a couple things. It's going to get our board to a consistent thickness, right? It's going to take us to our final thickness. In other words, we're going to take a board from an inch thick to 3/4 of an inch thick. almost probably just, if not more important, is the fact that it creates two parallel spaces. In other words, no matter where we measure the thickness of this board, anywhere we measure it, it's going to be the same. If these two surfaces shot off into space, they would never get closer together and they would never diverge. They'd never get farther apart. That's the definition of parallel, okay? So create two parallel faces, all right? That's the thicknessing process. Creates two parallel faces, creates a board with consistent thickness, final thickness. So once we have two good faces, all right, we can come back to the joiner. We can joint one edge. We can do a good job of it. Be effective. And the nice thing about waiting to joint the edge is that it doesn't matter which face you would put against the pins. And that helps you if the grain direction is messed up in one way. If our grain direction is going this way, I don't know if you can be able to see this. On this board, it's going this way. If our grain direction is going that way, that would be the proper way to feed it in this joiner with the grain direction. If for some reason we had it like this, okay, with both faces flat, it doesn't matter which face we put against the fence. We can easily flip it, use the other face against the fence, and go with the grain. That allows us to do that, where if we only joint one face and then come to the joiner, we're stuck with either that face against that flat face got against the fence. We can't alter that grain direction on the joiner. So we thickness it, get two parallel faces, then we joint one edge. What that gives us, what that gives us, let's go back, let's just do this. Down a little bit. Whoop, I went up. I think I figured this thing out by now. All right. Once we have both faces jointed, then planed, and we have one edge jointed, what we've created, we've taken care of two of the 90-degree angles. This edge to this face, and this edge to that face. Those are both 90 degrees, okay? Then we go to the table saw, and we do what's called, I'm gonna grab this other board. On the table saw, we're gonna make a rip cut, which is a cut in that direction, okay? We're altering the overall width of the board. And on the table saw, we're going to take our board 99% of the time down to final accurate width. As I said, there's exceptions to this all the time. But on the table saw, as long as that table saw blade is 90 degrees to the table, this would be our jointed edge. If we rip this edge and that blade was 90 degrees to the table, this edge was placed against the fence. What we've done is we've accomplished a couple different things. We've created two more 90-degree angles, that one and that one. Okay, 90 degrees to that face, 90 degrees to that face. And we've also created two parallel edges. Just like we created two parallel faces on the joiner and the planer, now we've created two parallel edges. So in other words, no matter where we measure the width of this board, it's going to be the same. It's consistent, all right? So that was faces, then edges. Joiner planer, joiner table saw, okay? From there, we go for a cross cut to deal with the end. That's a cut in this direction. We're altering the overall length of the board, okay? On the miter saw, most of the time, we're cutting to final accurate length, okay? Remember, if you have to cut more than one board to the same length, you must use a stop. It ensures consistency. It doesn't necessarily ensure accuracy, it ensures consistency, so that every one of your cuts that are supposed to be, say, 12 inches long are all the same. They may not be dead on 12 inches long, but they will all be the same. Picture the rungs of a ladder. If every step or every rung on the ladder is a different length, that's going to be a messed up looking ladder, okay? If you were cutting the rungs on a ladder, and you wanted those rungs to be 12 inches long, the steps, you set a stop to 11 7/8, they end up being an 1/8 inch short, but they're all exactly 11 7/8. You're not going to see it in the final build of that ladder. It's going to look just fine. Okay. So remember, more than one board cut to the same length requires use of a stop. When we make that cross cut, and it takes 2 cuts to cut a board to length, the first cut trims and squares one end. That's going to create 90 to that face, 90 to that face. It's going to create 90 to that edge, 90 to that edge. That's your first cut. The second cut is cutting the opposite end to get it to final length, and also assuming that the miter saw is set up properly and it's 90 degrees to the table and 90 degrees to the fence, you're going to end up with your last 4 90-degree angles. That one, that one, that one, and that one. So we have 12 separate 90-degree angles we need to produce on this board. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Every one of those angles, every one of those intersections of 2 surfaces needs to be 90 degrees. Okay? Faces, edges, ends. All right? Every time, just like that. Okay? So, there was something else I wanted to cover in this. All right. So we've talked about dimensions. Okay? The thickness of a board, the width of a board, the length of a board, 90 degrees at every intersection of 2 surfaces. Those are all dimensional, measurable things. We can take a tape measure. We can measure the final length of the board, the final width of the board, the final thickness of the board. It's all dimensional. Those 90-degree angles, okay, that's the structure of the board. That's something we can measure with a square. What we cannot measure is grain, okay? For example, this board has no grain. There is no face grain. There's no edge grain. There's no end grain. There's nothing that needs to be taken into consideration when we mill this board, when we cut it, saw it, whatever we do to it, whatever process we do to it. There's no consideration that needs to be taken in regards to what should we do first, what should we do second, what precautions do we need to take to prevent tear out or splintering or something like that. It's an enigma. It has no grain direction. It will do what it does. On the other hand, a board like this, we have to take into consideration how that board and its grain is going to react to being cut, okay? I was trying to think of a different analogy, but what popped into my head was really stupid, so I'm not even gonna bother. So grain direction matters. We have 3 distinctly different grains on any board like this. We have face grain, we have edge grain, and we have end grain, okay? All those different materials, all those different surfaces are gonna react differently to being milled. So here's an example. Okay, this is a piece of maple. You can see the grain direction in this board is going this way. All right, so that should tell you that this is end grain and this is end grain. This is edge grain, this is edge grain, face grain, and face grain, okay? The grain direction or the look of the grain, the way it's presented in a board, tells you what is end grain, what's edge grain. But in the same sense, this, even though it's end grain, would be considered an edge. It's longer than this surface. Dimensional, dimensions only. If I say face, edge, end, I'm talking about dimensions. Well, how long is this compared to how long is that? But if I'm saying grain, face grain, edge grain, end grain, I'm talking about the physical characteristics of this board and how it's going to react to a router bit or a panel saw blade or anything like that, or to a sander or to a chisel or a hand plane, okay? End grain reacts, you should know, really differently than edge grain or face grain does, okay? When it comes to planing or chiseling or routing or anything like that. So 2 different things, dimensions, right? Edge, edge, end, end, and then characteristics. Edge grain, end grain, face grain, face grain, dimensions, right? This board is just under 12 that direction, just over 12 that direction. So that is an edge, that is an edge, that is an end, that is an end, that's a face, that's the opposite face, that's dimensional. There is no grain, so there is no face grain, edge grain, or end grain, okay? So that is actually really, really important in regards to the way you look at and the way you process a piece of material, okay? And mainly, if you look at it, a lot of our machines have fences in here, right? We have a rip fence on the table saw. We have a fence on the joiner. We have a fence on the miter saw. There's actually a fence on the panel saw and the panel router. There's a fence on the dado saw. We can place fences on the band saws. What else am I missing with a fence in here? Let me see. There's a fence on the router table. Just, hey, oh, I was just going to ask this question, and thank you. Okay, there's a fence on the router table. In which direction do we put a board through the router table? From right to left against the rotation of the bit. It's the same way on just about every machine in here. Every time we feed a board into a machine, we're feeding against the rotation of a cutter or sanding belt. Okay, what do we got here? So I'm gonna go back to my share screen thingy. All right. So my whole goal here is, assuming they bring you guys back at some point, my goal here is to see to it that you are ready to take the safety test the first day you walk back, so we can get it done, get it out of the way, and get you guys started on something. Because depending on when they bring you guys back, assuming they do, there's not going to be a lot of time to accomplish much, and I don't want you to waste it on getting ready for a safety test, okay? So I will keep doing this as time goes by, as we're going over different machines. I'm sorry I'm not able to go through the planer right now because I'd have to move the camera and all this stuff to the other side of the shop. We'll do that on a separate day. We'll do the planer and, I don't know, probably the planer and the miter saw. But I'll continue to put these questions here. I want you to be aware, though, you're looking at this screen right now. I'm going to go to my website, and you guys should all know this. It's gphsmanufacturing.org. All right. And as usual, if you go to traditional woodworking, down here towards the bottom, here's the safety test. Here's the safety test with all the answers. Okay. Here's the major tool ID packet right here. Also, as I told you yesterday, here is the link to the Woodsmith Library, where you can start to search through some issues and look for things that you might want to do. Remember, we won't be choosing giant projects or anything like that. Not even when they bring us back. If, let's say you're in advanced and you also have this class the following quarters, we're not going to do a bunch of big projects, because if for some weird reason cases spike and they shut us down again, it's just a mess. So I'll come up with a few projects that you guys can consider if you want me to, and you can kind of take a look at some of them. There's some nice small projects that you guys can do. But I really hope you guys get back in here soon. This is getting a little bit out of hand. All right. So that's kind of that. Let me get off this screen share. So you should know where to find the safety test. You should know where to find all that stuff. I recommend, I'm going to go back to the share screen. There's something I want you guys to see. Please, it used to be, and correct me if I'm wrong, but I could have sworn that when I made an announcement, it showed up at the top of the home page. So as soon as you logged in and it goes straight to the home page, that's where it showed any new announcements. I placed an announcement on here this morning, and it does not show up on the home page. It only shows up in announcements. So I'm going to go to student view. Maybe. Okay, so do me a favor and check the announcements regularly. The only one I have here now is please be on time to class. Okay, it's important, especially when we're out in the shop, that you guys are on time. But I want to try and figure out why do you guys remember announcements from last quarter? Did they show up at the top of the homepage, or did you always have to go to announcements to see them? I swear they showed up at the top. But
honestly, I don't remember.
I could have sworn they showed up at the top, but I can't remember either. So anyway, the modules, like I said, any day we're out in the shop, usually by the next day, I will have the video lecture posted. It may take me a little more than a day sometimes. They take quite a while to upload and blah, 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 and all that stuff and convert. But so, for example, tomorrow sometime, it'll be in a little indented line here that says Tuesday, November 17th lecture. So if you missed part of it or something like that, it'll be in there. Like you want to watch me on video any more than you want to watch me here live. I wouldn't want to watch me. I'm not a lot of fun to watch on video. So that's kind of that. And I will generally, on a regular basis, they did. Yeah, that's what I thought, Jasmine. I could have sworn they did. And I'm going to find out why. Because it makes no sense to make an announcement and somebody have to go to the announcements to see it. It should show up right in your face when you open up the homepage. So like I said, they're going to start recording students that are not engaged in class. In other words, if they're not participating and when a question is asked, they're not answering. So I will from time to time pop a little question in there and give you 10 or 15 seconds to answer it. And if you don't, then I will send your name up to the front office as disengaged, and they will start contacting parents, guardians, whoever they have to contact to try and get you out of your bed and into class. If I were you, I'd start getting used to it because they will bring us back eventually, and I would get used to getting up and getting on it. I still get here at 5 o'clock in the morning. I haven't changed the thing because I know when you guys get here, I don't want to start getting here. You know, there's no way I couldn't do this getting here at 7:15. So, all right. So, thank you for being here. I appreciate it. Thank you. If you were here on time, thank you very much. If you were not here on time, shame on you. You better be here on time tomorrow. Remember, being here each day, remember there's 5 points a week for attendance. You make 3 out of 5 classes, you're only getting 3 points. Folks, you cannot fix that. At the end of the quarter, you cannot go back and go, please, Brandon, please give me 5 points for that week I was gone 3 days so I can pass. Doesn't work that way. Okay, so please be here. If you cannot be here, contact me via email and tell me why. If you're going to miss some time, be sure to get a hold of attendance and get it cleared so it's an excused absence, okay? And other than that, thank you again for being here. Take care of yourselves. Tomorrow's hump day. Thank goodness it'll be the downward slide of the week. Get your name in the chat for me and take care of yourselves, and I'll see you guys tomorrow, okay? That's it for today.
Mr. Brandon, guess who decided to show up?
Yeah, I saw that right when I was going to talk about which direction do you feed a board on the router table. That's interesting.
Yeah.
How's it going?
You should know the answer to that.
Zeph, you need to wake up, dude.
Yeah, that's my fault.
Yeah.
100%.
Do I have to call you every morning at 4 and wake you up when I get up?
That'd be fantastic.
I already established that with him.
Yeah, maybe I will. I get up about 4:15 every day. I'll just call you and make sure you're up. All right.
All right, that sounds like a plan.
Yeah. All right, bud. Thanks for showing up at least.
Yeah.
All right, guys. See you tomorrow, man. Thanks.
See ya.